Hi, I'm Luke, and I'd like to talk about my final project. The goal here is to detect street digits from trained on the SVHN dataset, which Google released in 2011. This problem is an object detection problem. It's a bit harder than maybe just pure classification because we need to find multiple digits in an image and also annotate them, and they might be overlapping. So the goal would be to look at a scene like this, which is unstructured and more complex than the SVHN dataset, find the 1, the 0, the 6, annotate them, and then draw their bounding box as well. So my generalized strategy was step one, extract patches of interest using MSER, classify those patches using a CNN model that just determines whether or not something is a digit or not a digit, threshold it at over 90%, filter those patches using a multi-labeled what digit CNN model, also thresholded, and then from the remaining patches that are like probably definitely a digit, remove overlapping candidate regions with n non-maximal suppression, and filter them out, then draw them on an image or a frame and make a video out of it. And my data pipeline involved taking the uncropped data, which was like about 50,000 images, and then splicing out each digit in a bounding box. Like the 7 would be stretched to a 32 by 32 image here, and also randomly extract negative examples from instances that are not in the bounding box, and then stretch them out here. This ensured that my classifier was not biased towards digit classes. I then fed this data set, the binary version, to the localization classifier and the detection version to the multi-label classifier, and went from there. So here's an example of what MSER does in step one. It just extracts a bunch of interesting patches. These are of different sizes. These won't fit into the CNN. So I had to take all of these and resize them to 32 by 32, then feed them into my localizer. Fed them into my localizer, which was a simple, shallow, 4-stage COBNet architecture. If the patches were highly competent that they probably contained a digit, I then fed them to a second classifier, which was the more complex VGG architecture, where it then spit out the likelihood of the specific class that was contained within the patch after that patch was filtered for probably containing a digit. And then finally, I used non-maximum suppression to threshold the final candidates and then plot them. So my results were competitive across the custom CNN with the VGG CNN from scratch. Ultimately, the Scratch VGN was about identical to the pre-trained one, so I ended up using that one. It was like 1% better. And then I used the custom CNN for the localizer too, because it was shorter and faster, and I'm analyzing lots of different patches, maybe 1,000 or so. Here are the results. It worked, right? Pretty cool. It draws things light, dark, different depths, big, small, and my video also works. I would say one thing that I learned with this video is that I probably should have rotated my training data a little bit more. So you can see it also has some false positives, like the 0. It thinks the circle, like a circle is a 0, and also the 1 is the edges of the window. But in the future, I could augment the training data and improve it, but it works pretty well. And in the future, I can increase the training data. I could try a sequential head, which would be learned to generate sequences, not just per digits in isolation, use a more complex trainer, or search more hyperparameters. Thank you.